Alright class, this is my third attempt at lesson 66. The first one my computer shut off. The second one didn't save on top of the first one. So here we go, take 3. It'll probably be shorter than the other two combined. So let's give it a whirl. We're going to do square roots. More square roots. This lesson is called Simplification of Radical Expressions, Square Roots of Large Numbers. So we're going to start with a quick review. I'm going to show you the square root of 50. And we're going to remind ourselves how we simplified this. What we did in class was we talked about how this isn't totally simplified. It's like leaving a fraction like 4/6 like it is. Everyone that looks at it that knows anything knows it's not reduced. Well, the same with this. When you see the square root of 50, you know it's not reduced. It's not simplified, so we're going to simplify it. The easiest way to simplify this might not be the easiest, but the quickest way is to locate the biggest perfect square that will divide evenly into 50. So I'm going to write the list of perfect squares down here. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, etc. 49, that's a 36. Things stop working. 64, 9 times 9 is 81, 10 times 10 is 100. These are our perfect squares from 2 squared to 10 squared. So we look at the list with the biggest perfect square that will divide evenly into 50, and we can say, oh, it's 25. So we divide it into the biggest perfect square, which is 25, and then what's left, which will be 2. Both of them are under the radical. We can split that up. We learned that property in class last time. 50 is the same as 25 times 2. We can split numbers, products up under the radical. Simplify the first number. Square root of 25 is 5. Comes out. Square root of 2 is not a perfect square, so it doesn't come out, and that's our answer. That was a quick review. So let's try an example from this lesson. We're going to be simplifying expressions. This is just one term. Expressions are more than one term. So we have the square root of 18 plus the square root of 8. This is now an expression because it's 2 terms. It doesn't have an equal sign. If it had an equal sign in a number, it would be an equation. So we're going to simplify each radical. Why don't you turn it off and see if you can simplify the radical like what we did here, and come back in a minute. Alright, let's simplify this. So we look at 18 and we say, what's the biggest perfect square that divides into 18? So we look over here. Biggest perfect square would be 9. 9 goes into 18 2 times, so I'm going to do the square root of 9 times the square root of 2. The biggest perfect square that divides into 8 is 4. So square root of 4 times the square root of 2. That simplifies. Square gives what times itself gives me 9. Well, 10 silly things here. 3 square root of 2 plus 2 square root of 2. They're alike radicals, so we can add the numbers in front of the radicals, so we get 5 square root of 2. Let's try another one. If you can simplify the radicals, then these problems are very easy. This one, 8 square root of 27. Plus square root of 8. There's a difference on this one. We now have a number in front of the radical before we simplify it. The 8 is multiplied times this. It would be a 1 right here. So these are multiplied together. So whatever we take out, we're going to multiply by 8. So we get 8. Square root of 27, the biggest perfect square that divides into 27, go to our list, is 9. So we have the square root of 9 times the square root of 3. The biggest perfect square that divides into 8 is 4. So we have the square root of 4, square root of 2, and 9 times 3 is 27, 4 times 2 is 8. We can divide them up into separate radicals, or we can put them back under one radical. Now 8 and the square root of 9 is 3. Remember I said we multiply. And here we're going to get square root of 4 is 2, square root of 2. Keep simplifying. 24 square root of 3 plus, oops, something went wrong on my problem here. You'd think after doing this 3 times I would get this right. I copied the problem wrong. So let's just finish this one. 2 square root of 2. So there's nothing else you can do on this one. So if you can't add them together, you just say that's it. So that's the final answer for that. Why don't you try the one that we were supposed to do? It's 8 square root of 27 minus, I combined 2 problems I think, minus 3 square root of 75. So stop the video and give this one a try. Alright, hopefully you got the whole entire answer. Let's try it. So we're going to get 8. Biggest perfect square that goes in 27 is 9. We're left with a 3. That's the same as this one up here. Should have been easy. Minus the biggest perfect square that goes into 75 is 25 times 3. We're going to end up with the same thing, 24 square root of 3 on this one. And here we're going to get 3 times 5, so it's 15 square root of 3 on this one. These, this time, we have square root of 3, square root of 3, so we can subtract the numbers in front, and we're going to get simply 9 square root of 3. So you just do these each individually. Don't forget to multiply. This would be the 8 times 3 here. Don't forget to multiply those, and if what's under the radical are the same, then you can add the numbers in front. Okay, let's move on to square roots of large numbers. I need to get a new screen for that. And I like working with a black canvas, so here we go. Square root of large numbers. These are large numbers. They look scary, but they're not bad. So we're going to simplify the square root of 50,000. If you're going to take, if you have an even number of zeros, like if I have the square root of 10,000, I have an even number of zeros, so it's a perfect square. If you just have a 1 with an even number of zeros, the square root is half the number of zeros. So we have 4 zeros, so the square root of that would be 100. Similarly, like if I had the square root of 100, I have 2 zeros, it's going to be 10. No block today. And I can get bigger, like if I do 1 million, it has 6 zeros. So the square root of 1 million would have 3 zeros. See how that works? So what we're going to do is, obviously there's not a 1 there, so we have to separate. And what you're going to do is just take out the 5, and then we're going to, it would be times 10,000. 5 times 10,000 equals 50,000. So I did the same thing, only I'm trying to get an even number of zeros with the 1. So we're going to get the square root of 5, 10,000, 1, 2, 3, 4. So it's going to be half of that, so it's 100 square root of 5. Let's do another one. What happens if there's not an even number of zeros? That's a problem. Let's try 500,000. 1, 2, 3, 4, 5. That's not even, so we have to make it even. And this is easy enough. We're just going to take one of those zeros out along with that 5. And that's going to leave us with 1. It's going to leave us with 1, 2, 3, 4 zeros. 10,000. We know that 50,000 times 10,000 is, that would be 50,000. I didn't have enough zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, that would be, that's, never mind, that's 500,000. So now we can simplify this. We know that there's, so we take it out, we're only going to have 2 zeros. Remember, the square root of an even number of zeros is going to be half the number of zeros. And then we have the square root of 50. The only problem is square root of 50 is not simplified, as we saw the first example we did. So 100. 100. And then we separate that in the square root of 25 times the square root of 2. So it would be 100 times 5 square root of 2. 500 square root of 2 would be your final answer. Let's try another one, and then you can do the last example on your own so you can get it. So this one is, we're doing 40 million. 40 million. A lot of zeros. We count them. 1, 2, 3, 4, 5, 6, 7. So with an odd number, so we're going to take one of them out with the 4. And that's going to leave us with 1 million. Even number of zeros with a 1, so we know it's a perfect square. The square root of a million would be half the number of zeros, so it would be 3 zeros. So we get 1,000. Square root of 40, and we can tell that's not simplified. So we're going to get 100 square root of 4 times the square root of 10. 100 times 2 square root of 10, and that would be 200 square root of 10. That's a simplified version of square root of 40 million. Okay, last problem, we try this. After you write it down, pause the video, and then come back when you've got it. The last one is 700 million. Numbers are getting bigger. Pause the video and come back in a minute. Alright, hopefully you counted the zeros. You have 6, 7, 8. That's even. So that's good. So we have the square root of 7 times 100 million. That would give us 700 million. 1, 2, 3, 4, 5, 6, 7, 8 zeros, so we need 4 zeros. So it's going to be 10,000. And the square root of 7 is simplified all the farther it can go. Square root of 7. So that's how you do large numbers and how to simplify expressions. And hopefully this one will save properly and I won't have to do this again. Thanks. See you Thursday.